so we've done quite a lot of work on vectors. We've looked at the I and J form, we've looked at magnitude and direction and how to convert between the two. So now we're looking at the angle between two vectors, which is really important for when we get onto modelling and looking at forces, etc. So the easiest thing is just to go through an example. So we've got two vectors here, 2i plus 6j and minus 7i plus j, and we're asked to find the angle between those vectors. So first thing we need to do is draw a picture. You can't really do this question without having a diagram in front of you in order to direct you as to what to do next. So if you could pause the video and see if you can just sketch those two vectors from the same starting point. Okay, so imagine it's the origin, so draw vector A and vector B both travelling from the origin. Okay, so you should have something like this. Okay, so vector A is 2 across 6 up, roughly. Okay, and vector B is minus 7i plus j. Okay, so it's not accurate, it's just a sketch. Now, if we want to find the angle between these two vectors, okay, we are looking for this angle here. Okay, now the easiest thing to do is to make this into a triangle. Okay, because then once I've got a triangle, if I can work out the length of this side, the length of this side, and the length of the third side, I can then use the cos rule. Okay, so if we put that third line in, that vector in there, okay, we then need to consider what that vector is. So it's going from this point to this point. If you remember with vectors, it doesn't matter the route you take, the vector will be the same. So I don't know the vector from here to here, but I know I can get there from doing negative A plus B, or B minus A. Okay, so that's what this vector is called. It's called the vector B minus A because it goes from there to there. Okay, so I now need to work out the length or the magnitude of each of these three vectors. Okay, so using Pythagoras, okay, you should get that vector A is the square root of 2 squared plus 6 squared, and vector B is the square root of 7 squared plus 1 squared, which gives you root 40 and root 50 respectively. Okay, so that's those two. Then I've got to work out B minus A, so I've got to work out what that vector is first before I can work out the magnitude. So B was minus 7i plus j, and we're subtracting A, which is 2i minus 6j, plus 6j. So minus 7 take away 2 is minus 9, and j minus 6, j is minus 5j. So it's always a good idea when you've calculated a vector just to go back to your diagram and see if that makes sense. So if we come back up here, to get from here to here, it says minus 9 minus 5. So minus 9 would be going this way and minus 5 would be going this way. So that does make sense, okay? We're going negative, negative. Okay, so now I'm happy that that's the right vector. I need to work out the magnitude, so that's the square root of 9 squared plus 5 squared, which is the square root of 106. We've got 81 plus 25, 106 is the square root. So let's write those on our diagram then. So we've got A, the magnitude of A is root 40. The magnitude of B is root 50. Okay, and the magnitude of B minus A is root 106. And again, that looks about right. This vector is longer than these two. Okay, so we're happy with that. And this is the angle we're calculating. Okay, so if you remember, if we're using the cos rule, we need to label our sides. Okay, so if I call this here angle C, and change that colour. Okay, we'll call that angle C. Okay, then this side here would be little c, and let's call this A because it was a vector A anyway, and we'll call this one B because it was vector B anyway. Okay, so if you remember your formula, cos C is A squared plus B squared minus C squared all over 2AB. Okay. Okay, so here's the cos rule. Okay, and because I left my answers here for the modulus, for the length, in exact form, it makes filling this in nice and straightforward. So the modulus of A was root 40, so A squared will be 40, and the modulus of B was root 50, so root 50 squared is 50, and so on, same for root 106. And then at the bottom, I've got 2 times A times B, which is 2 root 40 times root 50. Okay, that's the formula from here, and then of course I'm inverse cosing to find the angle, which comes out as 100.3 degrees to 1 decimal place. Okay, so steps: draw the diagram, put in a third vector and carefully work it out. Find the magnitude of each vector and put it on your diagram, and then use the cos rule to work out the necessary angle. Okay. So exercise 2.3 has got some questions just based on finding the angle between two vectors. So have a go at those.